Hello students, today's agenda is to check homework. We'll be learning about periodicity, symmetry, and behavior, and you will be able to do 6.2. Today students will be able to identify where the graph has periodicity, if it is symmetric, and what type of end behavior it has. So what does it mean for a graph to have periodicity? It's when the graph repeats, and we use periodicity, for example, in heartbeats, or if we're looking at the waves of earthquakes, sometimes they have some sort of pattern, okay? And so that's when it's said to have periodicity. How often or how long does it take for it to repeat? That's called a period. And sometimes a graph might have periodicity only between certain spaces. And I know this is not perfect. Let's say that if this was all the same, that the same thing was going on and on, then we can say that it's repeating starting like from here, and then it's repeating up to there. Okay, again, it's not perfect. I was doing it hand-free, but that's the idea. And so we can say that the period in here is how often does it repeat? Well, for this graph, you can see that it starts right here, it goes down, up. Then it doesn't go down, because sometimes people think, oh, it touches here and then it touches in here, that's two spaces. But no, it goes down and then it goes up. Then again, it repeats, goes down, it goes up. It's not how many times it goes up and down, how many times it repeats. No, it's from here to here. It goes down and it goes down and up. And then we can say that from here, a new period starts. It goes down and it goes up. So how long does it take for it to repeat again? How many spaces are there? So we say 1, 2, 3, 4. So the period in here is 4 spaces or 4 units. Okay, so 4 units. In here, we can say that the graph has periodicity. The graph has periodicity, and it's when it's between, for x, it's 1, 2, 3, 4, 5, 6. It's from 0 to 6. And here we can say the graph has periodicity when x is greater than 0 but less than 6. Okay, so between those 2 points. And again, I apologize for it not being perfect, but it's just to give you an idea. Okay, it's not periodic. It can be periodic only in certain spaces, okay, certain parts of the graph. It doesn't have periodicity in this other section or here, but between this area it does. Now, what's the period in here? I'm sorry, again, that's why I made it widespread in here at the beginning and then closer together so that it will be appropriately. So if you notice, it starts at the top, goes down, and then up. Then again, it starts at the top, goes down, and then up. Goes down, and then up. How long does it take for each time or for each pattern to repeat? So it takes 1 space, 2 spaces. 1 space, 2 spaces. 1, 2. Okay, because from here to here, it's 1, 2. Then from here to here, it's again 2 spaces, and so on. So we can say that the period for this one is 2 units. How long does it take before it starts to repeat again? Now let's talk about symmetry. There are 2 types of symmetry. The first one is even symmetry. And even symmetry is when a graph is symmetric about the y-axis. That means that it reflects on the y. Okay, you can fold it and this will meet with this. And it says that if x, y, and I'm missing is on the graph, then negative x, positive y is also on the graph. What does that mean? Okay, If we have this graph in here and we trace it like that, it means that, let's say that this point right here maybe being 1, 1, and then negative 1, 1 is also on that same graph. And what happened? If you fold this, the two dots will meet. And the same thing will happen in here. It's not exactly, but again, you can fold it and it will meet, right? Let me, except that this one is a parabola. This point should meet over here. So again, if you fold it, those points, positive, positive, negative, positive. It's when y is the same, right? It's positive, but then the x is the one that changes the sign. Now, the other type of symmetry is odd symmetry. And that's when the graph is symmetric about the origin. Basically, this is a rotation, a 180 rotation, 180 degree rotation. It says if xy is on the graph, then negative x, negative y is also on the graph. And basically here, let's say that this point is right here. Let's say that if we have 3, 1, then on the other side, the 3 will change to negative 3. The 1 will change to negative 1. And you can see that in here, negative 3, negative 1, right? So this point is 3, 1. This point right here is negative 3, negative 1, right? So you change the sign on both x and y. Now let's look up with the transparency. Okay, so if we rotate that 180 degrees, it's right there. See, you rotate it 180 degrees, and whatever is in here will match with whatever is down here. Another example in here is this one right here. Again, let's trace it. Okay, 180 degrees. So this one right here is pointing up. But now we rotated 180 degrees, so that's 90 degrees, that's 180 degrees, and there it is. They match again, okay? So again, for the even, you just fold it and they match. In here, you rotate it 180 degrees and they match. They also call it double fold. Why? Because if you fold it, let's say this is the original. If you fold it twice, and this paper is kind of a little stubborn, so let me try to do my best. If I fold it like that, I did one fold, and then I fold it on X again. Then they match. Okay, that's for the odd. For the even, you only fold it once. So they call this as one fold. So we can say that for the even symmetry, it's a one fold or one flip. For this one, is double fold. Or even better, a rotation, a 180 degree rotation. Okay, and again, if it has one fold, that's even symmetry. If it has 180 degree rotation, then it has odd symmetry. Okay, the last concept that we're going to learn is end behavior. And there are two types of end behavior. The first one is called diverge, which means that it moves away. But also from here, you can say that the end behavior goes to the positive or to the negative infinite. But we'll see more detail with that one in a minute, okay? But if you think about it as going to the positives, what's happening with my line? They're going away from each other, right? They're getting apart. That's diverging. Not only that, but we have to look at the line. Is the line going away upwards or downwards? If it's going up, that's going to go to the positive infinite. If it goes on the other side right here, look, this is for x, this is for the line. What's going on with my line? Again, it's diverging and it's going to the negative infinite. It's going away, but towards the negatives. Convergent, it just means approaching a specific number. And let me show you in here. So it doesn't matter what's going on in the middle of the graph. What matters is the end behavior. End behavior means like the tail, okay? The tails on each side. So what's going on in here? This is not going towards infinite. It's going and approaching 0 for y, okay? But it's approaching x on the value of 0 for y. Now in here, so we can say that as x approaches negative infinite, because it's going to the negatives, right? That's what's happening with the x, going to the negative infinite. What's happening to my end behavior? It's converging towards and we put f of x converging towards 0. Okay, converging just means approaching. It means approaching or getting closer to. For this other one, these are the positive end behavior. So as x approaches positive infinite, then it's converging. And if you notice, this time is not approaching 0, but rather I kind of marked a little bit in here. It's at 2, converging when y or f of x is positive 2. Okay? Again, diverging when it goes far away and converging when it approaches. A graph is not going to pass before 0. So we say that x is approaching 0. As x is approaching 0, then f of x will go, and it's diverging because it's going away, right? It's going away from x. Look at that, look at that. It's going away from x, so it goes to the positive infinite. And on this side, as x goes, on this side, it does continue. So what's happening? It's converging, right? It's converging. And it's approaching. So as x approaches positive infinite, then f of x, then f of x converges to 0, right? It's converging on this side. Again, the easiest way of doing this is it going away from x? Yeah, it's going away from x, and you can say, oh, it's going away towards the positive or towards the negative. So f of x will be going towards infinite positive. F of x will be going towards the infinite negative because it's going down. But in here, it's converging because it's approaching, it's getting close to a specific number, and then it's right there. It stays kind of right there. Okay, that's converging. And we'll practice with more graphs so that it's a little bit more clear. Now that we reviewed some, I have some graphs in here. And so I'm going to be answering some questions about each one of them. So the first question is, does the graph have symmetry? If yes, is it even or odd? So in here, I look just at the middle of y, because remember that even just means that I can fold it and they will match in here. And for now, just for that one question so that we understand, I'm going to ignore this because I added that just for the end behavior. So let's pretend that this one doesn't have this, or even this part right here. Even if it has this right here, what we're looking is, yes, it has even symmetry, because if I fold it in half, this point will meet with this one, this point will meet with this one, this point will meet with this one. So yes, if we have like that, it's yes, and it's even. What is the period, if any? Well, I look, does it have any periodicity? Again, I just added those in so that we do the end behavior, but ignore those for now to answer these ones to understand the other questions. So what is the period? The period, again, is when it repeats. If we look at, and you can start in any that make it easy for you to see. Let's start right here. Top, then it goes like a slide, then up, then right there it goes down like a slide, and then up. Then yeah, it's repeating like this often when it goes down and up, down and up. And it will probably continue if I hadn't put those down and up. Okay, so how long does it take from here to here? Well, it's 1, 2, 3, 4 spaces, or 4 units. That's for graph A. Then the next question is, what is the local maxima? Local maxima, it's these points right here. This one, and this one. And so we can just look by counting 1, 2, 3, 4. -4, +2. So -4, +2 is one local maxima. Another one is 0, 2. Another one is 1, 2, 3, 4. +4, +2. What is the local minima? Local minima will be this one right here. So it's 1, 2, 3, 4, 5, 6, -6, -2, -6, -2. This one is also another local minima. That's from the last lesson, which is going to be in the link of at the end of this video. So if you need to review that, you can go ahead and do that. -1, -2, -1, -2. Then this is another local minima. So 1, 2, -1, -2. So +2, -2. What is the positive end behavior? So for this one, I drew the arrow and I ruined it for the other one, for the other questions. But again, if those arrows were not there, this will be the answers. And for the end behavior, as x approaches positive infinite, so positive infinite, it means this end behavior. F of x approaches what? We can see, is it going towards the negative infinite or positive infinite? Because it's not convergent to anything, so it's going to the negative infinite. That's, for this part, we're just looking at the y values. Is it going towards the negatives or positives? Well, going down is towards the negative infinite. Number 6, what is the negative end behavior? As x approaches negative, okay, negative infinite, it just means the left. And so f of x, or meaning the value of y, is approaching what? It's going towards the positive infinite because it's going up. So basically, if it points up, it's positive infinite. If it points down, it's negative infinite. And then if it curves like that, and then it continues on and on and on, then that's converging towards a number, okay, towards a number. But in here, But in here is not converging, is both of them are diverging, going away from the x-axis. Okay, same questions for graph B. Does the graph have any symmetry? If yes, is it even or odd? Well, if we fold it on Y, yeah, it matches. This little hand matches this little hand. Okay, so yes, and it's even. What is the period, if any? I don't see any repetition in the graph, so no or none, because there is no periodicity. What is the local maxima? Because it has arrows, it means that it goes infinitely up. So no, it does not have any maxima, so we put none. So none for the maxima. What is the local minima? Minima is the lowest point, and so it's -2, so we put 0 for x, -2 for y. What is the positive end behavior? Positive, it means as x approaches the positive infinite, so as this one goes up, what's going on that side? Well, it's shooting up, so it's going to be positive infinite. What is the negative end behavior? As x approaches negative infinite, then what's going on this one? If it shoots up, it's going to be also positive. The end behavior is positive infinite. Okay, let's go with our third graph. Says, does the graph have any symmetry? If yes, is it even or odd? We look in here, if we fold it, even if I took away the end, because I put that just to give more examples of the end behavior, even then, it's not going to match exactly. Why? Because this looks similar up to here, but then these are not in here. So no, and that's all you have to say. When there is no symmetry, just put no. What is the period, if any? So in here, we can see that there is some repetition. I know that these are a little wider, but these are repetition, and we say yes. Actually, it's asking what is the period, if any, not if there is periodicity or not. So yes, we have periodicity from here to here, only in a section of the graph. And how often does it repeat? Well, it goes bump, bump, bump. How long does it take for each bump? Oh, it takes 2 units. Okay, so 2 units. What is the local maxima? In here, it refers to all the points that are up above. So it would be this one, this one, this one, and this one right here. So it's -1, 2, 3, 4, 5. One of them is a -5, +1. The other one is a -3, +1. This one is -1, +1. And this one right here is +1, 3. +1, +3. What is the local minima? Local minima are right here, this one right here, and this point right here. So 3 of those. These are not local minima because it continues to go down and down and down. Okay, so some of those points will be -4 and 0 because we don't move up or down on y. This one is -2, 0. And this one is 0, 0. Again, what is the positive end behavior? Positive end behavior means as you go positive on x, so it's just that part right there. What's happening in here? Oh, f of x, meaning the value of y, goes towards the negatives, right? The values of y, it's pointing down, so negative infinite. What is the negative end behavior? Negative end behavior means as x goes to the negative. That's why it's called negative end behavior. X is negative infinite. So going that way, just look at that part right there. And so what's happening? It's pointing down, so also negative. If he points down, negative infinite, going towards the negative infinite. Okay. If he points up, the end behavior is infinite, positive. And here, both of them are negative, infinite. And our last graph. Does the graph have symmetry? If yes, is it even or odd? Well, we'll look in here. If we fold it on Y, this point will reflect right there. But if we rotate it, let's move this out of the way. If we rotate it, we have a little hill on the right side. So 90 degrees, 180 degrees. We have a little hill on the right. Okay, let's bring that back. Does it have symmetry? Yes. Because it has a 180-degree rotation, we say that it's odd. What is the period, if any? So again, if we ignore that, we have periodicity because it's a repetition, right? You can see that it's repeating. How often? Careful, because we don't want to come from here to here and then from here to here, because it's not repeating like that. It's not going up, down, up, down, up, down. It's going up, down, even more down, up. And then again, up, down, even more down, up. So one period is this right here. And then it repeats again. Okay, the same pattern repeats again. So how long does it take for one of those repetitions? Well, it takes 1, 2, 3, 4 units. So in this one is 4 units. What is the local maxima? So it refers to these 2 points. So it will be -1, -2, -3, +3. -3, +3. This other point is +1, +3. And those are the only 2 local maxima. What is the local minima? The local minima refers to these 3 points. And so it's -1, 2, 3, 4, 5. 1, 2, 3. So -5 for X, negative for Y. Okay, the next one is -1, -3. And the last one is 1, 2, 3, +3, -3. Finally, what is the positive end behavior? Well, as X goes toward, approaches positive infinite, just refers to that one, is shooting up. Up is positive infinite. On this one, what is the negative end behavior? As X approaches negative infinite, what's happening to Y? It's converging. So you're going to put converging because it's approaching, and it's approaching 0. Okay, converging towards 0. And so I just want to analyze this a little bit more. Look at the other ones. It's pointing up or pointing down. But in here, all of a sudden it stays at one point or close to one point because it never touches it. It just stays close to it. Okay, so that's when you put converging and at what point on Y. And the other ones, if it's pointing down, it's approaching negative infinite. If it's pointing up, it's approaching positive infinite. Okay. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do 6.2 and have fun.